Hello pre-calculus students, and welcome to our continuing series of videos here on properties of limits. In the previous video we talked about limits of sums and limits of differences. Here we're going to look at limits of products and limits of quotients. And these statements, they don't say much, but they are very helpful, and hopefully you can appreciate them because they're not exactly simple to prove, okay? And it took a lot of thinking by some very good minds in order to figure this out. But this is saying if you have a limit of two products, then it's the same thing as taking one limit of the first product, of the first function, taking the limit of the second function and multiplying them together. So this is a way of saying the limit of a product, the limit of a product is the product of the limits. The limit of the product is the product of the limits. The limit of something times something else is the limit of the first thing times the limit of the second thing. Same thing with the second statement here. This is just saying that the limit of a quotient is the same thing as the quotient of the limits. And I should note here that g of x cannot be equal to 0. So the limit of a quotient is the quotient of the limits. And let's see how these ideas come to go to work for us. So let's look at the example 3 here. The limit of 1 minus cosine squared divided by x as x approaches 0. So now some false starts that we can think about here. Well, what if we try to break this up, right? What if we did limit as x approaches 0 of 1 over x minus the limit as x approaches 0 of cosine squared over x. Okay. Well, this isn't wrong, okay? This is correct, but not helpful. And the reason it's not helpful is because we still end up with division by 0 here. We still end up with division by 0 here. It's not entirely obvious what's the limit of cosine squared over x. So now we're going to apply something a little bit different and recall that cosine squared plus sine squared is equal to 1. So therefore, sine squared is equal to 1 minus cosine squared. So now this thing, I'm going to use a different colored pen here so we don't get everything all mixed up. But we can take this limit here. This is really equal to the limit as x approaches 0 of sine squared divided by x. Now, this still isn't that straightforward, but now we can apply the product rule here. We can say the limit as x approaches 0 of sine of x over x times the limit of sine over x over 1 as x approaches 0. And I want to make a note here that sine of x over x times sine of x over 1 is equal to sine squared of x over x. Okay. So the limit of a quotient, a product, this is essentially the product we're dealing with, is the same thing as the product of the two limits. From number 1, from the first example we did, we know that this is equal to 1. And this, well, it's pretty straightforward. We can do direct substitution. Now sine of 0, which is just 0, so 1 times 0 is equal to 0. Okay. So there you have it, a way for us to evaluate these limits algebraically. And of course, you can always do things graphically as well, but it doesn't always work well, and it doesn't It's a great way to check, but it's not always, guaranteed to give you what you're. So you should be able to practice and really work through this using your logic in addition to. And another point here is there's a lot of ways to go about this. There's a lot of ways to do this problem, but some of them are not necessarily wrong. They just don't help. They lead you to somewhat of a dead end. Okay? And so it's really just a lot of practice and trying to able to break this problem, this something that's unfamiliar, into bits and pieces that we are familiar with. We do know how to evaluate this. We do know how to evaluate this. So that's why we go this route. This route here, and again, not wrong, it just leads us to more uncertainty. And there's other routes that you can go to that will not necessarily be helpful to you, but is also not necessarily wrong either. Okay, but so you want to pick the solution here. And it's really just, sometimes just trial and error, just practice doing a lot of examples before you can really see the solution. So it might be a little bit of a struggle, but keep working at it. If you work at it enough, I promise it will get better. As always, ask for help if you need it. Thank you for watching. Have a wonderful day.